Valles Chasma is the widest segment of Valles Marineris, the largest canyon in the solar system. In this region, hydrated sulfate salts have been detected and are found extensively throughout the canyon. These salt-bearing deposits likely indicate that water was present in the past. Other theories include wind-blown sediment deposits and volcanic ash. This observation shows many interesting features that are common to Valles Chasma. At the north end, we can see typical spur and gully features that also mark the rim of the Valles Marineris throughout the canyon system. Emanating from the troughs, we see debris flowing towards the bottom of the slope. The floor of the valley shows sparse exposures of bedrock, which is otherwise covered in dark rippled dunes. Slopes in the north and south reveal layered sulfates that were deposited into the canyon system, and subsequently eroded to reveal the layered sulfate-bearing rock. Although Mars is a cold, barren desert today, the planet had a watery past with ancient river valley networks, deltas and lake beds, as well as rocks and minerals on the surface that could have only formed in liquid water. Using high-resolution images from several Mars orbiters, scientists recently identified a system of fan deltas in Valles Chasma that record the highest stand of an ancient ocean in Mars. Valles Chasma is a 600 miles long canyon system, which is part of the Valles Marineris canyon system. The geomorphologic structures, preserved today as scarp-fronted deposits near the lower end of the canyon system, closely resemble classic river deltas on Earth and mark the point where sediment-laden rivers once debouched directly into a standing body of water. Valles Marineris is the largest canyon system on Mars, where previous mineralogical studies had already hinted at long-lived water activity and possible shorelines. Earlier evidence for former water and a putative ocean in this region came mainly from detections of water-altered minerals and from less precise topographic and morphological indicators. The new mapping now provides a clearly defined coastline, demonstrating that a substantial ocean filled the low-lying northern hemisphere of Mars roughly 3 billion years ago. To build the reconstruction, scientists combined high-resolution color and stereo images from several Mars orbiters. The images helped scientists systematically survey and map the geomorphology of the southeast Valles Chasma sector, identifying mountains, deeply incised valleys, and sedimentary accumulations that define a coherent depositional system. At the foot of one mountain range was a set of fan-shaped sediment bodies with steep, scarp-like fronts, which scientists interpret as fan deltas that prograded into a long-lived water body. Fan deltas form where debris and sand carried by rivers and gravity flows accumulate directly into lakes or seas, creating lobate constructs with well-defined fronts. The mapped Martian fan deltas show the same organizing principles seen in Earth analogs, where rivers enter oceans and deposit their load at the coastline. This similarity strongly supports interpretation of the Coprates chasma deposits as the preserved mouths of rivers entering a broad ocean basin. The identified structures represent the clear geomorphic expression of river mouths feeding into an ocean, rather than into a small, confined lake. From the elevation of the delta fronts and associated shorelines, scientists infer that the ancient ocean filling the northern lowlands of Mars was at least as extensive as the Arctic Ocean on Earth. The study therefore provides robust evidence that Mars was once a blue planet, with a major ocean occupying much of its northern hemisphere and an active hydrological cycle feeding sediment from high-standing terrains into marine basins. Today, the original delta morphologies are partly masked by wind-sculpted dunes that drape the deposits and surrounding plains, yet the underlying fan geometries and scarp fronts remain clearly visible. This preservation allows scientists to reconstruct the former shoreline despite billions of years of Aeolian reworking. The confirmed presence of extensive fan deltas and a large ocean has important implications for past habitability on Mars. Long-lasting bodies of surface water, coupled with active sediment transport and deposition, create diverse environments where chemical gradients and mineral surfaces can support the emergence and evolution of life. Sand dunes commonly form when particles that are being moved around by the wind find a natural barrier to accumulate and build a hill-like formation. Scientists study dunes because their shape and size can give valuable information about the wind directions and speeds in current and past climates. For instance, Barkhan dunes are crescent-shaped, and they form when the wind blows mainly from one direction perpendicular to the crescent long edge. On the other hand, star dunes have 3 or more arms and form in environments that are affected by multiple wind directions. The observation here shows an area on Mars with both star and Barkhan dunes next to each other. This implies that wind directions have changed with time, or that the surrounding landscape is creating complex wind patterns. Scientists can study high-rise images collected over time of the same dunes to observe whether they are moving or not, and if so, how fast. By observing multiple dune systems over many seasons, they can get a better picture of wind regimes on Mars and possibly how they have evolved with time. This view from the Pancam on NASA's Mars Exploration Rover Opportunity looks back toward part of the west rim of Endeavour crater that the rover drove along, heading southward. Wheel tracks from about a month of driving on Mars can also be seen receding into the distance. The Opportunity mission had been investigating outcrops on the western rim of Endeavour crater for 3 years. The crater spans 14 miles in diameter, and phyllosilicate-bearing outcrops have been detected along its rim. These minerals may have formed under wet conditions in a low-acidic environment during the early history of Mars. During Opportunity's first decade on Mars and the 2004 to 2010 career of its twin, Spirit, NASA's Mars Exploration Rover project yielded a range of findings proving wet environmental conditions on ancient Mars, some very acidic, others milder and more conducive to supporting life.